You know that little bit of magic that happens when you use an ATM? It's a piece of tech that's so smooth, so reliable, we pretty much take it for granted. But behind that simple cash withdrawal is this incredible story, a story about how all the world's banks learned to speak a secret, universal language, and it all starts with a question we've all probably wondered about. I mean, really, think about it for a second. You could be in a totally different city, maybe even a different country, using a machine owned by a rival bank, and somehow it just works. How is that even possible? How do these competing companies trust each other enough to make that transaction happen in just a few seconds?
Well, to really get why the solution is so brilliant, you have to understand the original problem. So let's rewind the clock a bit, back to a time before this global network existed, back when every bank's ATM network was its own little private island.
Picture this. It's the mid-'80s. You're on a road trip and you're running low on cash. You see an ATM, finally, but it's not your bank, so it's totally useless to you. Your money is basically locked away in a digital vault hundreds of miles away. That was the super frustrating reality for anyone who used an ATM back then.
But that exact frustration, that's what sparked a huge innovation in modern finance. All these competing banks started to realize, hey, we've got to cooperate if we want to actually serve our customers. They had to build bridges between their separate, isolated systems. And this is where interbank networks were born. All of a sudden, these logos like Surus and Plus started popping up on our bank cards and on the ATMs themselves. Now, these weren't banks. Think of them as the essential middlemen, the switchboards that connected everybody to everybody else. And let me tell you, this was an absolute game changer. Suddenly, your one little bank card became this magic key that could get you cash from this massive interconnected web of machines. The convenience that we just expect today, it was born right here, from this simple but totally revolutionary idea. Okay, so the banks are connected, we get that. But how does the information fly back and forth so incredibly fast? How does a machine in Miami instantly know if you have enough money in your account all the way back in Seattle? Well, it all comes down to a lightning-fast digital handshake. It feels instant, doesn't it? You pop your card in, punch in your pen, and the machine starts whirring. But in that tiny slice of time, your request is going on this wild journey, potentially flying across the country and back again before you even hear the cash start to count. So here's the play-by-play broken down. First, the ATM reads your card and encrypts your PIN. It packages all that up and shoots it off to the network, Cirrus or Plus. That network is like a super smart traffic cop. It immediately knows where your home bank is and zips the request over there. Your bank system gets the message and does the all-important check. And finally, it sends a simple yep or nope all the way back, and that ATM spits out your money. Now, let's zoom in on that one step, the check at your home bank. In just milliseconds, its database has to answer this rapid-fire set of questions. Is this card even active? Are the funds actually there? Did the PIN match? Oh, and should we tack on a fee for this? It's a real-time interrogation of the bank's central records. Okay, but here's another puzzle. How can an ATM made by one company running one type of software in New York talk to a giant bank computer made by a totally different company running something else entirely in California? They need a common language. They need a Rosetta Stone for money. And that language is called ISO 8583. Now, you'll never see it as a customer, but it is the invisible grammar that holds this entire global system together. It's a standard that dictates the exact format for any message, a withdrawal, a balance check, you name it, so that every single system in the chain can understand it perfectly.
So what does one of these messages look like? Well, it's not a sentence, it's just pure structured data. You've got a message type code like 0200 here means, hey, this is a transaction request. Then you have the card number, the exact amount, a timestamp down to the second, and the ID of the specific ATM making the request. Every single system knows exactly where to look for each piece of information. No translation required.
So when you take a step back and really look at what they built here, you realize it's so much more than just a convenient way to get cash. This network, it was a monumental achievement in the history of data and computing. Seriously, think about that for a moment. This was happening before the public internet as we know it even existed, before global e-commerce was a thing. This system was, for all intents and purposes, the world's first massive real-time database that connected competing commercial businesses across the globe. I mean, this was a huge paradigm shift. It forced companies that were natural rivals to learn how to talk to each other in an instant, to keep their own separate records perfectly in sync. And, this is the big one, to trust a shared neutral system to handle billions and billions of dollars. So every single time you tap your card at a store, buy something online, or Venmo a friend, you're using a system whose technological and even philosophical DNA can be traced right back to these pioneering ATM networks. They proved it could be done. And that just leaves us with this one really fascinating question. This system, this incredibly durable foundation of modern finance, was built 40 years ago. So as we're moving into this new era of crypto and AI and instant digital payments, you just have to wonder, what's going to be the next revolutionary language that all of our financial systems learn to speak?